For the next example problem, we will be analyzing a weaving segment in the same facility, I-90 northbound. My weaving segment is located right here at the middle between these two interchanges, and it's bounded by the on-ramp from I-94 and the off-ramp to High Crossing Boulevard. So this will be the segment that we'll be studying here. And all the required input data is listed here, as you can see. Quick discussion about geometry. You'll notice that for this weaving segment, we have 3 upstream approaching lanes plus 2 on-ramp lanes, which at some point will give us a cross-section of 5 lanes. But if you look closely in the map, you'll notice that there is a lane drop downstream of the merge. And for most of my weaving segment, I'm going to have a 4-lane cross-section. And that's what we'll be using in our analysis because that's the most conservative approach. Keep in mind, this is done based on engineering judgment. That's not one of the cases that's strictly discussed in the HCM. And with that, let's start by opening our freeways module in HCS. Let's start a new file, our freeway weaving segment. And let's start by entering number of lanes 4, as we discussed. We have level terrain. We have a measure of free flow speed, so I'm going to keep this box checked. And my field free flow speed is 65 miles per hour. My weaving segment is one-sided, so the on-ramp and the off-ramp are both located on the same side and connected through an auxiliary lane. I have 3 weaving lanes because here I have an option lane that gives my drivers extra flexibility. For the freeway to ramp maneuver, I have a minimum of 0 lane changes, so no lane change required. And for the ramp to freeway maneuver, I have a minimum of 1 lane change that's required. My short weaving length is 7,350 feet, and I have an interchange density of 0.33, which corresponds to adjacent interchanges, one immediately downstream, one immediately upstream. So 2 over 6 miles gives me a rate of 0.33 interchanges per mile. Let's then proceed to our ramp inputs. I have 2 ramps lanes in the on-ramp and 2 lanes in the off-ramp. Both of them have a free flow speed of 35 miles per hour, and that will be used to check capacity on the on-ramp and the off-ramp. And finally, let's proceed to our volumes. For the freeway to freeway, I have 2,350 vehicles per hour. Freeway to freeway, 882. Ramp to ramp, 141. And freeway to ramp, 1,869. Demand adjustment factor, whatever you enter here, will multiply the demand. So that can be useful for future scenarios. In other places, it may be called growth factor. No changes are needed here. We have a peak hour factor of 0.91 for every single movement. And I have 17% trucks for every movement. I have no adjustment factors to apply here. All my drivers are familiar. And let's proceed to our report. And the first thing you'll notice here is that I am seeing a basic freeway report instead of a weaving segment report. The reason why this is happening, if I check the info box here on the top right corner, you'll see that the short length of this weaving segment, that's an input, is longer than the maximum weaving length, and that's computed internally as 6,554 feet. Or in other words, my weaving segment is too long, so the weaving maneuvers are negligible, and the analysis is simplified to a basic segment. And with that, that ends the first part of our hands-on problem. Next, we will make some changes in one of the input volumes, and we will see what happens next. For the second part of our example problem, we want to evaluate what would happen if we change one of the volumes, the free weight ramp, from 1869 to 2800 vehicles per hour. In order to do that, let's return to our file, let's return to our input page, and let's locate the free weight ramp field, and let's change this to 2800 vehicles per hour. And then let's go back to the report. The first change you will notice is that now we have a proper weaving report. So you may conclude that this maximum weaving length is dynamic. It's function not only of geometry, but it's also function of the traffic volumes that I enter in the model. You'll see here a summary of all my geometric inputs, adjustment factors, and my volumes. You'll see here, as discussed in the theory, we have two different capacity measurements. The first one is based on the average density, and that is about 8,000 vehicles per hour. But we have a second measure that's based on the weaving flow in my segment, and that is about 5,000 vehicles per hour. And this will be the limiting capacity. So that's the number that I take as my segment capacity. And that would lead me to another operational issue, which is now I have demand to capacity ratio over 1 or 1.35, which means I have a bottleneck here. And as discussed in the theory, that will automatically give me a level of service F. And you also notice that no performance measures are provided. If you want to check the warning message again. That's consistent with HCM guidance. When we're doing this single segment analysis, if level of service F occurs, we should expect oversaturated conditions to occur. That means queues will develop in the freeway. And in order to take that into account, we need to provide a full freeway facility analysis, where we need to evaluate how queues behave across multiple segments and across multiple time periods. But for now, we'll not be able to proceed with this analysis. So the only thing we can get really is a level of service F. And that concludes our hands-on example for the weaving segment.